My name is Laura Marburger, and the title of this project is Finding the Most Effective Method to Extract Polyethylene Terephthalate from H2O. In this project, a droplet of water from numerous Nestle Pure Life water bottles were placed beneath a microscope to be observed. Separately, the minuscule sized samples were counted off with their initial amount of microplastics visible. Each slide used in this procedure was thoroughly cleaned to limit contamination and therefore increase the accuracy of the investigation. Subsequently, the sampled water was divided into two groups of 10 in each. Group 1 would utilize a certain filtration method, whilst Group 2 would utilize a second technique. Non-toxic iron fillings were poured into the water sample and mixed in with the vegetable oil in the first group. Accordingly, magnets were used to extract the mixture and thus filtering out an abundance of the microplastics. The water was then put under the microscope and evaluated. The amount of polyethylene terephthalate particles that had been counted before and after were subtracted to find the remaining data. For the second group, each sample was poured through the carbon filter once and immediately examined. The carbon filter had been disinfected within each trial to, again, obtain a threshold on the quantity of contamination. The same process was pursued, and the microplastics calculated were deducted from the initial proportion of polyethylene terephthalate in each sample. These are original photos from the researcher while the experiment was being conducted. The first one being a sample of the water under the microscope as it was being evaluated. The second being the water bottles that had been used in this project. And the third, the vegetable oil utilized in the first group within its filtration method. In both of the data sets, there were occasional spikes and lows in the graph, which only goes to show that both filters can be more productive and less productive depending on the starting point of the microplastics. Although the first filtration method did show a larger spike than the second filter, the activated carbon had higher numbers overall in terms of how many microplastics were extracted. After the filtration was applied in Group 1, and subtracted from the initial amount of microplastics counted, the mean of the data is 79.6, the median is 103, and the mode is 65. In Group 2, the mean is 80.5, the median is 69, and there is no mode. From this information, it is safe to tell that the second method, the carbon filter, worked more efficiently within the area of extracting harmful microplastics. These are the sets of filtration methods, the first one being Group 1 and the second set being Group 2. This is the initial observation all the way on the left. Following that one is after the filtration method. They were both tested under the microscope, and this is what they observed and what they looked like after they had been filtered. The second set was the initial observation in Group 2. And then once it had gone through the carbon filter, that is what it looked like in the following filtration method after it had been filtered. These are original photos from the researcher while the experiment was being conducted. The first filtration method was most likely less efficient because the ferrofluid mixture was not combining and the magnets were small and inconsistent. Because of the magnet size, some of the powder may not have been fully filtered out and therefore caused smaller amounts of the polyethylene terephthalate to be extracted. The second filter is much more complex compared to the ferrofluid utilized in the first group. It is specifically made to extract these certain microplastics, henceforth there weren't nearly as many problems occurring with this filter in contrast to the first group. Since it specializes in the area of polyethylene terephthalate, it is only reasonable that it would work more efficiently than a hand-made filter.